Okay, so hopefully the first couple steps you were able to generate. But what about the general equation? Can we do this one now? Is it getting more familiar? Let's see. I'm going to pick on the west side now. Let's see here. Who's got an idea how they might write down the general equation? Andrew, you look like you're just trying to avoid it. You're staring so hard at your page, so I'm going to see if, let's see. Can you?
Pi over 2.
Okay.
Pi n.
Yeah, sounds
N is in
perfect. See? You were just so bored by it that you weren't paying attention, right? That's okay. Okay, so again, if you look at the pattern here, it moves over by pi each time that it keeps going. So here is the first asymptote, and then I move over by pi. I'd find the next one if I kept going by pi. It also works for negatives. Take away pi, keep going. You keep ending up on top of the asymptote. Okay? All right, so this is it. Let me just tell you here, in your exam specifications, this is the absolute worst you could see for this type of question. Your exam specifications say that's the most they'll do to you. They will not give you a translation. They'll just give you some horizontal or vertical stretch factors to deal with. So let's see if you can do these two questions. See if you can find the period, the asymptotes, and a general equation for those two transformed graphs. Okay, so I'll do the first one here. Hopefully everybody's up to that point. The period of this graph, I can see this has a horizontal stretch factor of 2. That I don't really care about. It won't really change anything in this graph because all the features are horizontal stuff. Asymptotes, those are on x values. So this period of the graph is going to become 4 pi, twice what it used to be. And the normally what I'd be looking for, I'd be looking for where sine x equals 0, since I'm looking at the reciprocal cosecant. And I would find those at 0, pi, 2 pi, maybe I'll go one more, 3 pi, and so on. So now, what I've done is I've applied this horizontal stretch factor. So I'm going to be at 0, 2 pi, 4 pi, 6 pi, and keep moving. So that means I can come up with a general equation . 2 pi n, where n is an integer. Okay. And in the last example, if the horizontal stretch factor here is 1/2, that means the period will become half what it normally is. So it'll be pi. And this is the cosine's reciprocal. So normally I would be looking for values like pi over 2, 3 pi over 2, 5 pi over 2, and it would keep going. Now if I half them all, I'd be looking at pi over 4, 3 pi over 4, 5 pi over 4. So how much is the pattern jumping by each time? Yeah, pi. So I could write this down as pi over 4 plus, oops, that's not a plus. Let's just erase. No, that's not eraser. That's the eraser. So I could write this down as pi over 4 plus pi n, and everybody's favorite part, oh, sorry, it's pi over 2 then, right? Yeah, okay, so that's easy to fix. Yeah, so each one of these here moves over by pi over 2. It's all the construction behind us that's, I'm sure that's the problem. Normally I have flawless math skills. What are you laughing about? Okay, so that's it for today.